Hi, good evening again. This is Folorunsho Olushaki speaking from here. I just want to reinforce my learning strategies and what I've learned so far in thinking and doing, and my favorite problem too. What I would like to do is to extend what I did in the first reflection, that is, Sierpinski's triangle problem, to a square. I want to know how it's going to look like if I'm having a square, to know the area and general trend. If one quarter of square size is cut out or removed continuously. What I mean by continuously is that when you have a square, you know, when you have a square like this A not now, you have a square and you cut like okay A1. You cut this one away, what will be the scenarios? What will be the general phenomenon? What will be the general trend? Can we arrive at a general equation that we can use anytime, that we can use regardless of the square that we have, regardless of the number of the actually the square they have the same size, equal size, and at the same time, maybe next time I want to also extend it to rectangle. I want to also extend to rectangle, but for today, I just want to limit it to I would just want to limit it to square rectangle. Now, though I was so actually I have so many favorite problems in this course. But in my curiosity, I have to dive deep to extend the principle behind the Sierpinski triangle to a square, and at the same time to clear some error, if any, in the eyes of my future student. So let us go. Let us go. Now you can look at the the the, the the drawing that I have here right now. Firstly, let us draw the first square, which is A naught, right now, and as expected, area will be A naught. So we move into the A2. The A2, as you could see from here, you can see what I did in this place. A, B, C are the area that we need to consider. But as I mentioned from the equation problem that we are looking at, the in every scenario, each quarter of this square will be removed. From there, we follow the normal trend. So for the A1, the one quarter had to be removed, and the area of the one quarter that was removed is 1/4 A naught, which is totally cut off. So what will now be the area of the total? So you can see the clear analysis here. But some students might just assume that okay, they just add it up. They just saw A1, A2, just add it up, give it. But the reason behind it, I just wanted to know that you can add it up, but we can make an error. I can easily write 3/4 A naught. But some students might know, how did we arrive at this? So, as we have divided this square into 4, it means that the area of the A naught has been divided into 4. It means that A1 is A1A plus A1B plus A1C. So the next line gives us equal to 1/4 A naught 1 plus 1/4 A naught plus 1/4 A naught. When we add all of them together in form of just uh, addition of fractions, we now arrive at 3/4 A naught, which can be easily verified. So let us move ahead. So what of A2? What do we do from here? Now, for a clarity, you can see at the top left corner here, I wrote, because I wrote that 1 over 4 multiplied by 1 over 4 A naught, which is equal to 1 over 16 A naught. It means in this A2, each box, each square box, it has an area of 1 over 16 A naught. You could see the relevance of A naught from here now. It means as much as you continue to make a square on this A naught with the same size of the A naught, the area of each small squared will be a fraction of A naught. So students have to know this very, very well. That it's not, the area is not increasing, but the area is, the areas of constancy of A naught is how can I put it now? Is fragment. It's just piece by piece, bit by piece, bit by piece, and it's now decreasing. So you could see from what I calculated here. Now let us move ahead. We now have A2A, which gives us 3 over 4 multiplied by 1 over 4 A naught. Now A2B is 3 over 4 multiplied by 1 over 4 A naught. Likewise, 2C. Likewise, 2C. Now, the total area will now be A2A plus A2B plus A2C equals to 3 over 16 A naught plus 3 over 16 A naught plus 3 over 16 A naught, when is equal to 9 over 16. Now, this 9, this is another way of verifying what we are really doing here. Now, when you look at the remaining buses under A2, you will discover that the remaining buses is 9. Let us try to count it. Under A, one bus is already cut out as instructed from our question. You can now see that the remaining bus is 1, 2, 3, 1, 2, 3, 1, 2, 3, which is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 9. It means it will be 9 multiplied by 1 over 16A. This is another short way to reason it, to think about it in doing mathematics. So there are several ways you can go about this. It's not one way, but there are several ways you can determine the area of A2. So let us extend this to A3. If the trend will still continue, so that if the trend continue, that is good for us anyway, so that we can generalize a general equation from it. Okay, let us move ahead to A3. A3. Now, from this A3, the easiest way to do this one, which I'm going to talk about in my conclusion right now, is that, for instance, this, we have 27 squares here. When you count it one by one, you discover that you have 27 squares, having removing the quarter of each triangle square that we are creating. Now, the area of each square will be 1 over 64. How did we arrive at 1 over 64? Very simple. As I mentioned to us from A2, where I calculated from here, which is 1 over 4 multiplied by 1 over 4 A naught. This is 1 times 1, 1, 4 times 4, 16. The same thing apply in this place. All we need to do from here is just write 1 over 4 multiplied by 1 over 16, which gives us 1 over 64. This one I didn't write it down here, but just for the viewer to know what I did in this place. Now from there, we have A1 is 1 over 4 A naught. A2 is 1 over 16 A naught, we give us 1 more. Okay. Now, imply that A3 is 1 over 16 multiplied by 4, which go to 1 over 64. Now, which means each small unit is the fraction is the fraction of the main size, A naught. With this statement, it will help my student to know that even if they have missed it somewhere else, if they have missed somewhere, they can still recall, oh, this is not correct. It's supposed to be, the first one is 1 over 4 multiplied by 4. The second one is 1 over 4 multiplied by 16. The next one should be 1 over 4 multiplied by 164. And with this trend, because thinking and doing is a very is a nice way of doing mathematics. Now we now have A3 is equal to 27 over 64 A naught. Now this is the deed. Let us compare all the three scenarios: A naught, A1, A2, A3. 3 over 4 is a common factor to A1, to A2, to A3. What do we do? It's just for say A1 is equal to 3 over 4 raised to power 1. A naught. A2 is equal to 3 over 4 raised to power 2. A naught. A3 is equal to 3 over 4 raised to power 3. A naught. Now, you can ask A4 is equal to 3 over 4 raised to power 4. A naught. Now, what will now be the A5? If I may ask. The A5 will be 3 raised to power 4, or no, 3 over 4 raised to power 5 A naught. And it will continue like that. So we now from here we can generate a general formula which is AN is equal to 3 over 4 raised to power N A naught. Let us, for instance, N is equal to 1. If N, no, let's for instance N is equal to 0. What will happen? It means that A0 will be equal to A naught. We go back to the first triangle. So 3 over 4 is a common ratio. Finally, as I conclude, we can also use T-table. T-table could be used to analyze this scenario as well. It can be used to analyze this scenario. So I will just stop from here, and thank you for joining me. Bye.